Hi everyone. This webinar is going to address the benefits of wideband real-time RF signal recorders as it pertains to radar, EW, and signal intelligence systems. So let's take a look at some of the basic development challenges that RF systems engineers have. Our radar systems are using wider and wider signal bandwidths. The ability to capture and analyze that information is critical. Same thing goes for EW. Not only the ability to capture that, but the ability to manipulate and transmit those signals. Electronics intelligence systems, there's a wide range of RF signals that need to be spanned and looked at, and those signals then turn into the libraries that are used for classification and identification. Same thing goes for signal intelligence. There's a tremendous amount of data that's captured with any of these systems. And in the development of artificial intelligence algorithms, you really need to look at a tremendous amount of data. So some of the classification libraries that are developed for signal intelligence and electronic intelligence can be developed through AI algorithms, but first require the acquisition of large data sets. So let's talk about some of the specific radar development challenges that you'll see. Ultra wide bandwidth radar, as we mentioned, multiple gigahertz of capture bandwidth is required because of the very short sub-nanosecond radar pulses that are being used in some of these high accuracy radar systems. Frequency hopping has been around a long time. You see it in LPI radar. Again, you're spanning a large portion of the RF spectrum, so the ability to capture all that information is critical. High PRF radars are challenging because you need to have information about the timing of the range gate. And when that's happening at a very high frequency, there are certain challenges that need to be accommodated. And then a lot of people that are developing radar systems are not only interested in the gated acquisition period, but they're interested in the downtime in between. So having the ability to capture 100% of the duty cycle is a challenge. So some of the ways that we solve these problems is we provide very wide front ends to our recorders, the ability to capture over 2 gigahertz real time. So this is useful for both the very ultra wideband radars and for frequency hopping systems. And the way that we deal with some of these high PRF and 100% duty cycle capture situations is to provide certain features, the ability to timestamp packets on a sample level, very high accuracy, and the ability to also operate in a mode where you can capture 100% of the duty cycle. They're critical features. In addition to that, we've added custom features, but we've tried to solve every radar solution with different Talon recording systems. When it comes to EW, jamming is a technique that requires not only the receiving of the signal, but the analysis and the retransmission of it. Very similar challenges that you see to a radar system development, very wideband radars with frequency hopping, high PRF, 100% duty cycle capture. So again, we have very wide bandwidth capture solutions, and that's a critical part in an EW development situation. And again, we talked about the gated acquisition and 100% duty cycle capture being modes. The other thing that we have is very deep recording storage. So this allows for the EW analysis over time. Finally, and maybe the most critical part, is we do have the ability to play back signals. So signals can be manipulated and played back, and this is useful when you're testing an EW system. When it comes to electronic intelligence, the signal classification, requires that detection of the signal, and that's a challenge in itself. But let's go on here. The signal bandwidths can be very wide as well. You can see greater than a gigahertz wide bandwidth signal in an ELINT system. Developing these threat libraries requires you to have a lot of real-time storage, right? Because you're going to be looking for signals, latching onto them, and capturing them for long periods of time. The other challenge is you're not typically creating or capturing these signals in a benign environment. You're usually in a hostile environment, so you have to have a system that's going to be able to accommodate that. So one of the things that we're able to provide with our Talon recorders is the ability to scan the RF spectrum using our Sentinel package, which includes both the RF tuners and a scanning capability. This gives us the ability to look for these signals in the ELINT world. And we're able to provide a deep amount of recording storage. So again, electronic intelligence, capture of signals, bringing them back to the lab for analysis. We offer these recorders in a half ATR rugged form factor with excellent size, weight, and power. This allows us to put these recorders into hostile operating environments, and we have several other features, including encryption and secure erase, that allows these recorders to be out in the world looking and capturing signals. Signal intelligence has its set of challenges and solutions, but is not unlike electronic intelligence in the sense that it has to be able to detect and capture signals, and that you need that fast tuning and scanning capability. Frequency hopping can result in the requirement of wide bandwidth RF signal capture. So to have that tuning front end, but the ability to then have a wide bandwidth front end is essential. Again, long duration recordings, you might be latching on to a signal that you want to capture that could be recorded for hours at a time, or perhaps bouncing between signals. However, a deep amount of storage is typically required. And again, SIGINT is often placed in hostile environments. So again, the Sentinel with our integrated tuners, they provide quick scanning and detecting and capturing capabilities. Again, we provide a tremendous amount of storage in these recording systems, and that gives you the ability to really acquire a tremendous amount of data to be able to analyze over time. And again, we offer these in the half ATR rugged form factors. So again, able to get these into really hostile environments. I wanted to touch a little bit on artificial intelligence and how that applies to our real-time RF signal recorders. Some of the challenges is that artificial intelligence and machine learning is a wonderful thing for developing libraries for signal intelligence and electronic intelligence, but it requires a comprehensive data set to begin to learn on. So that's one thing. These real-time algorithms that then can be deployed, they need to be developed and tested prior to deployment. And as I mentioned with the comprehensive data sets, you really need deep storage to leverage this machine learning. So some of the solutions that we have, again, we're able to capture very wide bandwidth signals, so we're able to perform a full spectral analysis as a result. We have that very deep recording storage to provide those large data sets for machine learning. And then another thing that we have is the ability to customize our real-time FPGA signal processing. And this is something that can be leveraged in order to implement some of these algorithms. So let's talk about some of the highlights that we have in our recording systems, because this will give you a better idea of what we're able to do. First, we have sustained recording rates all the way up to 100 gigabits per second or 12.5 gigabytes per second. That's in a single chassis for a single channel. With hundreds of terabytes of storage, you've heard that throughout this presentation so far. Well, that can accommodate hours and hours of real-time recording. We provide these recorders as complete instruments with a graphical user interface. This is a really nice out-of-the-box experience and allows our customers to get up and running without having to do any type of software development or integration. We provide many different front ends. That includes both tuners and different A to D converters. So we're able to support different bandwidths, different dynamic ranges, and these systems are scalable, can accommodate many channels. We have many different form factors, and I'll get into that a little bit. We talked about the half ATR, but there are also several other form factors for operating in different environments. The ability to play back signals that were collected in the world and then brought back to the lab, really important in a lot of cases. Our signal acquisition, our multi-channel signal acquisition can be done either independently or phase coherently, but having phase coherent acquisition over many channels is often critical. We have a lot of features that we've developed into our systems over time, including the ability to customize the processing within the FPGA, the ability to timestamp and position track the recorder as it might be acquiring RF signals during a flight or during a mission, pulsed radar recording. As you see, there's front panel removable data drives, and we support all the standard encryption. We also provide an API that allows our users, our customers, to create their own interface. So while we provide this with a complete GUI, it's very easy to take it and develop your own. So one of the Most popular form factors we have are our half ATR recorders. These are optimized for size, weight, and power. They're built in a half ATR package, so you can see the height, weight, and depth of this recorder, and weighing in at 18 pounds really is a nice package. The power consumption typically ranges between 90 and 130 watts. So again, optimized for swap. And this is a full-up recording system. You know, we're talking about the tuner, the A to D converter, the processor, the disks, everything. That's quite a number to come in at around 100 watts. We provide a quick pack as a storage solution. This is a single drive pack that can hold up to 61 terabytes, easily removable by the user. That, along with the operating system drive, makes this a system that's easy to sanitize. And the recording rates currently go up to 4 gigabytes per second in this package. We're working on a next generation package that will double both the storage speed and the storage size. And again, this package supports a wide range of A to D converters and RF tuners. It can be controlled over Ethernet. Obviously, in a situation like this, you might have this in a UAV or even an aircraft pod. In the case of a pod, it could be remote controlled by a pilot, or in a UAV, it could be set up for autonomous operation. This system's been tested heavily. It's been through all of the 810 and 461 testing that you would expect. It's built in a sealed enclosure for very harsh environments. Tested from minus 40 to 55 degrees C with a startup at minus 20. Tested to an altitude of 60,000 feet, humidity, dust, sand, and rain, and then a level of RF emissions and susceptibility, both radiated and conducted. Again, this unit you'll often see in aircraft pods, in UAVs, military vehicles, and ships. And I say this product, it's really a set of products. We have a set of IF signal recorders ranging from 200 megahertz 16-bit A to Ds to 6.4 gigahertz 12-bit A to Ds with varying channel counts. Ones that are accompanied with RF tuner front ends, and you can see the variety of products that we have here. And then we have some digital signal recorders that include Ethernet and serial FPDP, but we also have a version of this coming out in 2022 that will use the 100 gigabit Ethernet interface to collect data from the RF SoC, and we'll talk about that in a little bit. In addition to our half ATR small form factor, we have some rugged rack mount recorders. These are 19-inch chassis with front panel removable solid-state drives. Again, everything is removable for quick sanitization. They have the largest storage capacity available of all of our Talon recorders. You can put up to 244 terabytes of storage in here. They accommodate the highest streaming rates, up to 12.5 gigabytes per second. Again, that corresponds to 100 gigabits per second. You'll see these used quite often in a lab environment, a test and measurement type of piece of equipment. We often ship these with transit cases, but they could be used equally as well on a desktop. But these are also deployable systems. They have been deployed in pressurized cabins and ships. We have quite a number on ships and in vehicles. They're fairly rugged. They can be installed in a rack, and again, they can be operated either locally or over Ethernet remotely. Some of the models of this recorder, again, ranging of different front-ended A to D converters for our IF signal recorders, our RF signal recorders that have the integrated tuners, and then the digital signal recorders. These are the models and the different front ends that we support. We also have a line of rugged portable recorders. This is a really nice package. It's great for moving from site to site, great for that test and measurement environment, but also works well in the field. Again, all of the non-volatile memory can be quickly and easily removed. It offers quite a bit of storage capacity, up to 122 terabytes, and accommodates record rates up to 4.8 gigabytes per second, although in 2022, we will be doubling those rates. Again, test and measurement, easy to get around the lab, and we have these deployed on aircrafts in cabins, as well as ships and vehicles. Here are the models we have for the portable recorder, a couple of different flavors with different A to D converter front ends, a couple different flavors with RF tuners, and then our Ethernet and serial FPDP flavors. Just a little bit about the graphical user interface. Again, this is intended and sold as an instrument that has a common interface from model to model, so it makes it easy for our customers to use any of our recorders and move between them as if it was the same unit. It provides that excellent out-of-the-box experience. You're up and running minutes after you take it out of the box. Point-and-click configuration interface, and all of the configurations that you create can be saved as profiles, so you can single-click return to them. It includes some signal analysis tools. Our SystemFlow signal viewer, again, integrated into every system that we offer. It's a nice tool for taking a look at signals prior to acquisition, during acquisition. You want that sanity that your recording is going to be okay. This gives you an excellent way of verifying your signals. It includes a virtual oscilloscope, a spectrum analyzer, and a spectrogram display, and does some basic signal analysis. Everyone really appreciates the ability to take a look at that signal that they're interested in recording and making sure it's real, and not having to head home with potentially some bad data on disk. The API, we offer this in different programming languages. Traditionally, this has been a set of C callable libraries, but we've extended that use as a lot of engineers that are coming out of school today know much higher level languages like Python and C#. Again, when someone's developing their own interface, it's typically because they have a place that they're at, like a cockpit, where they want to control the recorder that might be residing in a pod of an aircraft. So there's a gigabit Ethernet interface between the user interface that's created and the recorder itself. Again, it can also be configured to run autonomously when you're in an unmanned vehicle. And the recorder, it's being a recording system, it is built in a computer with a real-time or with an operating system, Windows in this case. And that, in a lot of cases, our customers are using this as the mission computer in their aircraft. So it can serve dual purposes as a real-time signal recorder and as a mission computer. We do a lot of customizations here, and the reason why is that our customer base often sees a product that we have, likes the features that we offer, and has something that they need a little bit different or that they want in addition to what we offer. So we often tailor our products to our customer specific needs, and that includes adding different RF tuners, so we're able to support not only the tuning frequencies and IBWs that you see in our standard products, but we're able to change this or to supplement this as need be. We often make changes to our FPGA IP. Again, this is on request. Some of the custom radar acquisition modes that we've created over time, some of the digital down converters might not have the decimations that are required for a particular application, or things like being able to acquire digital signals alongside the RF signal. These are all types of customizations that we have made and can make upon request. All of these systems are scalable, whether they're scalable within a recorder by adding signal acquisition cards, or scalable across recorder chassis. We're able to sell these as 1, 2, 4, 8, 16, 32 channel systems very easily. We often add software features, usability enhancements, custom modes of operation upon request. Wanted to talk a little bit about recording with the Quartz RF50C, since the Quartz RF50C is such a popular product for us. The Quartz RF50C models all provide two 100 gigabit Ethernet optical interfaces, and they are the fastest interfaces available on those cards for high-speed data streaming. In VPX form factor, the Gen 1 RF-SoC and the Gen 3 RF-SoC, the models 5950 and 5953, in The SOSA aligned versions for Gen 1 and Gen 3 are models 5550 and 5553. And we have a small form factor box version of this. Again, the Gen 1 RFSoC is the 6350 and the Gen 3 RFSoC is the 6353. We have recorders to support all of these models. So that recorder is the model RTR2757. Again, it has a 100 gigabit Ethernet interface that was specifically designed for capture from this product. So when I say specifically designed, I mean the front end card for the recorder, it matches the FPGA IP as the 100 gigabit Ethernet interface instantiated in the RFSoC product. So let's talk about this a little bit. The 2757, it has a QSFP28 port with an MPO transceiver. Again, it hooks up to the 100 gigabit Ethernet interface to Quartz. It can handle a 12.5 gigabyte per second, the full 100 gigabit per second rate from the Quartz product, and it includes that front panel removable storage, again, quick sanitization, but up to 122 terabytes of NVMe storage. In the current instantiation of the recorder, we accommodate the IP that's in the current instantiation of the RFSoC, which is the first 4 channels, the first 4 A to Ds are routed to 100 gigabit Ethernet port, where the second 4 channels is routed to a second. And the current 2757 can handle a single port, a single 100 gigabit Ethernet port. So we're able to essentially handle 4 of the A to D channels from the Quartz RFSoC with the current iteration of the 2757. So if you wanted to record 8 channels worth of data, you would need 2 of these chassis, and that's what currently a lot of our customers are doing. The next generation, something that we're coming out with in 2022, will accommodate 2 QSFP28 and MPO transceivers within the 2757 recorder. And we will be getting double the rate, 25 gigabytes per second, real-time recording, up to 244 terabytes of NVMe storage in the new model 2757. So again, the FPGA routes 4 channels to each optical interface. The new 2757 will handle all 8 channels in a single chassis. So let's go over everything today. First, we talked about the RF system design challenges in radar, electronic warfare, electronic intelligence, signal intelligence, AI, extremely wide bandwidth signal capture, deep recording storage. We talked about high PRF, 100% duty cycle capture. All of these different challenges are accommodated with the solutions that we offer. We provide high speed, real-time recording capabilities to support ultra wideband signal capture with that very deep storage. Again, we support a wide array of front ends. This accommodates different RF tuning frequencies, different bandwidths, and different dynamic ranges. We have 3 different packages that we showed you. The portable package, the Rackmount package, and the half ATR allows us to put our recorders in all different types of operating environments. We perform customizations all the time here. Again, that allows us to work with our customers to provide a solution that makes sense for them and to give them exactly what they need. And we talked a little bit about the RFSoC as well. Our recorders are currently supporting the latest of Xilinx RFSoC technology, and we will be continuing to go down that road by enhancing those recorders and doubling data rates and storage capacities. I really appreciate everything. Thank you very much.